Dear class, so in this video, we will talk about the application of inferential statistics and measuring the difference between variables. Now, there are 7 steps that we usually follow when doing hypothesis testing or doing an inferential statistics. The first step is to establish the null hypothesis, or what we call your H0. Now, as we have discussed in the previous sessions, the null hypothesis is a statement of equality between your variables. Number 2, the second step is to set the level of significance. Usually, it's around 0.05 or 0.01 or 0.001. When we want a more strict level of significance, we usually use the 0.01 level of significance, or your alpha, or the strictest one, which is around 0.001. Okay. Now, the third step in doing your hypothesis testing is to determine the type of test statistic. The fourth one, or the fourth step, will be to determine the critical value of your test statistic. And the fifth one will be to compute or do the actual computation. The sixth step is to make the decision whether to accept or reject the null hypothesis. And lastly, in hypothesis testing, you need to do or to interpret your findings. Now, before we begin with our discussion of this statistic of this video, or of the steps, in doing your Microsoft your statistical test in Microsoft Excel, I want you to download or enable in your Microsoft Excel the data analysis toolpack add-in. Okay, you can find this by clicking on the Tools menu and then click Excel Add-ins. Or if you have other versions of Microsoft Excel, you can find a help file where you can find the Excel add-ins. Once you click the Excel add-ins, this dialog box will appear, and you just have to check the analysis toolpack and then press OK. Just restart your Microsoft Word or Microsoft Excel, and then the data analysis toolpack will be enabled. Now, there are two major types of inferential statistics that can answer questions of difference. The first one is what you call your parametric tests, usually applicable for data that is at the interval and ratio level of measurement. So parametric tests can be used to answer the question, the difference between population and sample, which is your z-test. Or if you want to compare 2 sets of scores from 2 different groups. If that's your question, then you use an independent t-test. The third type of parametric test is your paired t-test, or if you're comparing 2 related scores that are either from before or after observation or an intervention. But if you want to compare the scores of 3 or more groups, you use a one-way ANOVA. For tests that are that involve the level of measure, the ordinal level of measure, and the nominal level of measure, we use the non-parametric test. Okay. For the equivalent of an independent t-test, we use a Mann-Whitney u-test. For the equivalent or the non-parametric equivalent of ANOVA, we use a Kruskal-Wallis test, or popularly known as H-test. In this video, we will primarily focus our discussion in parametric tests. So let's have an example for z-test. So we use z-test for comparing the means of a sample to a population. And if there's a significant difference between the sample mean and the population mean. So let's look at this example. So in this problem, it says that the IQ results of all employees in XYZ company has a mean value of 98 with a standard deviation of 8.53. There are 5 new employees who took the same IQ test with the following scores: 75, 89, 94, 72, and 100. Now, the question of the researcher is there a significant difference in the IQ of the new employees to that of the company's average? Now, it is important to note when doing a z-test to identify the population mean, which in the case is given. The next is to identify also the population standard deviation, which is 8.53 and 98 respectively. Now, we have to find what is the sample mean and the sample standard deviation. So if you will manually compute it and use the manual computation for the z-test, no, it will require you to compute the mean of all these scores and the standard deviation of all these scores. Luckily, we will be using a software, which is Microsoft Excel, to compute, no, the test statistic value for us. Now let's proceed to the computation or to the hypothesis testing. So the first step is to establish the hypothesis or the null hypothesis. So when we say null hypothesis, this is the statement of negation, of non-relation, of equality between your variables. So therefore, an inverse of the statement of the hypothesis or of the question of the researcher from the previous example will be the null hypothesis. So in this case, there is no significant difference in the IQ of the new employees to that of the company's average. The second step is to identify the level of significance. So by default, we use alpha of equal to 0.05. The third step is to identify the test statistic, which is, in this example, we use the z-test because we want to compare the sample mean to the population mean. Okay? The next step is to identify the critical value. In the manual computation, we usually identify it through a table, okay? Usually found in the appendices of your statistics book. But since we are using a Microsoft Excel program or a formula, which automatically gives us the p-value, which is the probability value, we have to set, okay, our critical value to our level of significance, because this is where we will compare our probability value or the p-value that we will get from the computation. Now, the next step is to get the z-value. As you can see, I already computed it as 0.992. How do I get it? We use our Microsoft Excel. Now, in our Microsoft Excel, we plot our data like this one. Now, these data are the sample IQ or the IQ of the new employees. I also included here the population mean of the company, of the population mean IQ of the company, and the population standard deviation of the company, which is the sigma. And this one is signified as the mu or the population mean. To get the z-value or the p-value for the z-test, we encode the formula equals z.test and then click this one. Okay, it will give you a syntax of array, x, and sigma. When we say array, this is the group of data that you want to test. X will be the population mean. Sigma is is your population standard deviation. All or each value are separated by comma. So to get the z-test value, first we get the array. So we highlight this one, and that's our array. We press comma and then select the x, which is the population mean, and then comma, select the value for your population standard deviation, which is your sigma, and then press enter. You will get a p-value of 0.9992. Okay, so therefore, in the z-value or the p-value in the z-test is 0.992. After getting the p-value, we compare it with the critical value of the level of significance. So upon checking, since the p-value is greater than the level of significance, as we have discussed in our previous module, we accept the null hypothesis. Therefore, we can say that there is no significant difference in the IQ of the new employee. Okay? Another test that we will be discussing for this video is your t-test. Now, a word before we proceed with t-test. Now, we have to remember that when we type the formula of t-test, it will give us, or we will use this syntax. Okay? Equal sign, t.test, open parenthesis array 1, which is your first data set. The array 2 will be your second data set. The third element is your tails. Okay. Now the tails, as we have discussed in our previous video, the tails will determine if you will be using one-tailed or two-tailed test. So to determine what's your one-tailed, or if you will use one-tailed or two-tailed test, you have to make sure, or you have to recheck your hypothesis. Okay. If the hypothesis is directional, you use a one-tailed t-test. If your hypothesis is non-directional, you say that it is a two-tailed test. And the type will also be required for the kind of t-test that you will perform. Because there are two types of, or two major types of t-test. Okay, one that is paired, and a two-sample equal variance tailed test. Okay? Now, a one-sampled or a paired t-test is a test used to compare differences of scores, two different sets of scores from one group only, while this one is used to determine the difference between scores from two different groups. Okay, so to help us in our example, or to help us to understand, we will have first our example for independent t-test. So in this example, there are two teaching methods that are being tested. Method A and method B from two student groups, two different groups. So notice that there are two separate scores from two different groups. Okay, so therefore, we are using independent t-test for this one. So the efficiency scores are determined. Now, the question of the researcher is there a significant difference in the efficiency of method A and method B? All right. So if you formulate a hypothesis for this one, or a research hypothesis, the researcher will say there is a significant difference in the efficiency of method A and method B. Now, we follow the 7th step in inferential statistics. The first one is to establish the null hypothesis. So the null hypothesis is a statement of equality. Therefore, we say there is no significant difference in the efficiency of method A and method B. We set the level of significance at 0.05 and identify the test statistic as independent t-test. Now, we identify also the critical value because we set our level of significance at 0.05. we set also our critical value at 0.05. And then we do the calculation. To arrive to this answer, to this p-value, we go back to our Excel sheet. So how do we do it? First, we plot our data as method A to method B. Next, we perform the t-test already. So to do it, we press equal sign, type the word t.test, and select this function. So the syntax will be given to you, okay? And select the first set of data separated by a comma. As you can see, I pressed comma here. And also select the second set of data and then press comma again. After you have pressed the comma, you arrive at the tails. So based on the hypothesis, it seems the hypothesis is non-directional hypothesis. Therefore, the null the tails of the test will be two-tailed. So you type there 2. Okay, and then press comma, then choose the type. Since we are doing an independent t-test, we choose the number 2. Okay, and then press enter. We arrive to a value of 0.66. So that's why the p-value here is 0.66. Now, since the p-value is greater than the level of significance, we still accept the null hypothesis. Therefore, we say there is no significant difference in the efficiency of method A and method B. All right? Now, how about if we're going to use dependent t-test? Okay, we use dependent t-test if there are two sets of scores that are related to each other. Okay, just like in this example, a group of students took an intensive review program. So before the start of the program, their knowledge about the subject is assessed. And the same thing was done after the review. Did the program improve the students' knowledge? So if you will look, okay, there's a pre-test score from one group of students, and there's a post-test score for another group of students. So these two are related because they came only to the same group of students. Okay? So that's why we will be using dependent t-test for this case. Now, we follow again the 7th step of hypothesis testing. The first one is to establish the null hypothesis where there is no significant improvement in the student's knowledge after the review program. Because this is a statement of no or non-relationship between your variables, no improvement at all. So you establish the null hypothesis. Next is to set your level of significance as at 0.05 and determine the type of test. Now, this is a dependent t-test that's one-tailed, that we're going to use a one-tailed test. Why? Because if you will look at how the question is framed, it's expecting a direction. It's looking on the improvement. It's looking on one side. Okay, so therefore a one-tailed t-test is appropriate for this one. Now we set again the critical value at 0.05. Now we compute for the t value or the p value. Now to do this, we go back to our Microsoft Excel. We plot the data for the pre-test and the post-test. And on this cell, we find the p-value. So we type equal sign, t.test, and then select this function. Select the first data set for the pre-test. separate it by comma, select this second data set, and then press comma. Now, since we're looking only for one failed test, we press or we choose 1. And then separate it by comma. And since we're doing a dependent t-test, this is 1. Press enter and you will arrive at 0.00369 or 37 or 0.003. So that's why this value is reflected in this step of the inferential statistics. Now that we know that the p-value is less than the level of significance, we reject the null hypothesis. All right? We reject the null hypothesis. Therefore, we can say that the review program is effective in improving the knowledge of the students. The last test that we will discuss is what we call your one-way ANOVA. Okay, your one-way ANOVA is meant to differentiate or to find if there's significant difference between scores from 3 or more groups. For 3 or more groups. Now, always take note that these data are all or should be in the interval and ratio level of measurement. Now, to best identify or to best explain on how to use one-way ANOVA, we take this example. So in this example, there are 5 students who shared their evaluation on 3 school softwares that were proposed to them. Now, is there a significant difference in their preference? So that's the question of the researcher. So these are their data, and these are the answers of the students. 1 row per student. Okay? So one student rated 5 for software A, he rated 2 for software B, and he rated 8 for software C. So on and so forth. Okay? Now, again, we establish first our null hypothesis, which is there is no significant difference in the student preference for school software. Okay. The next is to establish our level of significance, which is around alpha of 0.05. Okay, and determine the test statistic of our choice. Since we're comparing 3 sets of scores, from the three different sets of scores, we get or we use one-way ANOVA. The critical value is set at 0.05, just as your alpha. Okay, and to get your F or the p-value for your one-way ANOVA, we do it using Microsoft Excel. Okay, so we go to our Microsoft Excel, okay, and choose and plot our data for our responses. So for example, software A, software B, and software C, all of the scores are plotted for each student. Okay. Now, to get to perform an ANOVA using our Microsoft Excel, okay, I know this will only work if you have installed the data analysis toolpack that I have mentioned earlier. Assuming that you have installed the data analysis toolpack, just select the data and go to your data analysis. Now, this will give you several statistical tools that you can run using Microsoft Excel with this add-in. Just select ANOVA and the single factor ANOVA because this is a one-way ANOVA. Just click on the single factor, okay? And then for the input range, click this icon and select these fields for your data. And then Make sure that you you click the option that they are grouped by columns. Okay, by columns, because this set is for section for software A, this section is for software B, this section is for software C. So after you have selected and arrange your data, you click the columns under the group by section. Okay, and set your alpha or level of significance at 0.05. Okay, you can choose to place your output or the result of your statistical test in an output range, or you can use a new worksheet slide, which will give you another sheet here, or a new workbook, or a separate or totally separate new file. So let's have it on an output range, and we decide that we place it here. Okay, we choose that one. And then click OK. Microsoft will give you these values. Okay. Now, if you notice, these parts are also given to you. In the computation of your ANOVA, okay, sum of squares and mean squares are part of your formula. But since we used Microsoft Excel and we're expecting for a p-value, we look on this part. We look on this part, right? So the p-value is around 0.229. So that's why we placed here 0.229. Now, since the p-value is greater than the level of significance, our decision is to accept the null hypothesis, which says that the preference of the students in terms of the software that they're using are not different. Okay? That ends our discussion for measures of difference. If you have any question, you can always send me a message. Thank you and have a nice day.